In today's video, we will be discussing about Mathematics Paper 4, Mechanics 9709, 41, October-November 2021, Variant 41. Question number 1. A bus moves from rest. So bus starts from rest with a constant acceleration for 12 seconds. For 12 seconds there is a constant acceleration. It then moves with a constant speed for 30 seconds before decelerating uniformly to rest for a further 6 seconds. The total distance is 585 meters. Find the constant speed of the bus. So we need to find this constant speed, that is v. As we know the total distance table, we can calculate the area under the velocity time graph, such as half into sum of two parallel sides, 48 plus 42 into height, that is velocity which is unknown, is equal to total distance, and use it to find the velocity, that is 15 meters per second. Find the magnitude of deceleration. So we need to find the magnitude of this deceleration. This is a uniform deceleration, so we can use the equation acceleration is equal to final velocity minus initial velocity by final time minus initial time, and we get our answer as negative for acceleration, and for deceleration 5/2 meter per second square. Number 2. Two small smooth spheres A and B of equal radius and mass kmkg for A, mkg for B respectively, where k is greater than 1, and are free to move on the smooth horizontal plane. That means there is no friction. A is moving towards B with speed 6 meters per second. So A is moving towards B with a speed of 6 meters per second, and B is moving towards A with a speed of 2 meters per second. After the collision, A and B coalesce. That means they stick together. That means their combined mass is now km plus mkg, and move with a speed of 4 meters per second. So they move with a speed of 4, as we can see that A has a greater mass than B. Since A is multiplied with a constant that is greater than A, let's suppose this is 1.5 or it is 2 or whatever it is greater than 1. That means the mass of A is greater than the mass of B, and A is moving in towards right. So in total, A and B after coalesce would move towards right. And then we can equate these two equations, that is momentum before collision is equal to momentum after collision, and momentum is equal to mass into velocity, that is mass into velocity before collision is equal to after collision. And since B is moving in opposite direction compared to A and AB, its velocity is negative, and after equating this we find a value of k, that is 3. Find in terms of m the loss in kinetic energy due to collision. So we need to find the loss in kinetic energy. So kinetic energy is equal to half mv square, where v is the speed, or kinetic energy is equal to half mass into speed square. So it would have no direction, thus all the direction would be positive. Then initial kinetic energy, that is kinetic energy of A plus kinetic energy of B, is equal to kinetic energy that is 56 m, where m is a constant. And the final kinetic energy of total A and B after coalesce with a speed of 4 meters per second is 32 m. So change in kinetic energy is negative 24 m. Therefore loss in kinetic energy, therefore it is negative, so loss would be 24 m. Number 3. Coplanar forces of magnitude 24 Newton, 36 Newton, 24 Newton, 36 Newton, P Newton, and 20 Newton are acting on a point that is in equilibrium. So we need to find the horizontal and the vertical component of each of these forces, and since we know that sin alpha is equal to 3/5, so we need to find in perspective to sin alpha the value of cos alpha. Then for each horizontal component we find an equation, and for vertical component we find an equation. And since sin alpha sin theta by cos theta is equal to tan theta and p cancels out, so we divide second equation by the first equation and find the value of theta, that is 59.4 degree. So the value of p after substituting the value of theta is 18.65 Newton. Number 4. Draw a sketch showing the forces acting on the particle. So for the particle of mass 12 kg, the weight is acting vertically downwards, that is 12g, and its horizontal component is 12g sin 25, vertical component is 12g cos 25. Then is on a rough plane, that is friction is acting, is at an angle of 25 degree to the horizontal. A force of P parallel to the line of the greatest slope of the plane is used to prevent the particle from sliding down the plane. So this particle tends to slide down, but due to P, which is acting upwards, it prevents the object from sliding downwards. So P is acting upwards, and since the object tends to move downward, friction is acting in the opposite direction of motion, that is upwards. And these forces are, then in question number B, find the least possible value of P. So for the value of P, that is least value, for the object is moving downwards, therefore P plus mu r is equal to 12g sin 25 would be the least value, and for the maximum value, P would be mu plus 12g sin 25. This would only occur when the object is moving upwards, but since the object is moving downwards, we have to consider this equation. But this equation occurs when the object is moving upwards, therefore friction is acting downwards, and the component of weight is also acting downwards, and therefore to restrict this motion of, and for P to have a maximum value, that is when the object is moving upwards, this would occur due to P, that is P causes the object to move upward. P causes the object to move upward, therefore the friction, that is opposite to the direction of motion, is acting downwards, and the component of weight is acting also downwards. The object would only move upward when P is causing, or any force that is causing it to move upward. Therefore you can see that P as it would act upward, and friction and the component of weight is acting downwards, therefore this would give a maximum value. But you don't need to use this for this question right now, because we have already given an expression or any diagram or any event, and so in respective to this event we need to find the value of P. You can ignore this list part for this question because this is to make you confused. But for now, P plus mu r is equal to 12g sin 25, so the value of P is 12.65 Newton. But and also you can see that mathematically P has a least value when it is added to something that would give a least value of P, and this would give a maximum value of P, that is P is equal to some larger value that is added to this value. So this will give a maximum value of P, but you can ignore this for this question, and we use this equation to find the value of P. 5. A car of mass 1600, that is 1600 g, vertically downwards, with a constant speed 20 meter per second. As it mentions about the constant speed, that means driving force is equal to resistive force. Up the plane with an incline at an angle of sin inverse of 0.12 degree to the horizontal, that is the value of theta is sin inverse of 0.12. Theta is equal to sin inverse of 0.12, that means sin theta is equal to 0.12, and cos theta in respective to the sin theta, we calculate the value of cos theta. But for this question, find the change in gravitational potential energy for the 32nd. So we need to find a change in gravitational potential energy. Gravitational potential energy is equal to mass into gravitational field strength to height. We know the value of mass and the gravitational field strength, but to find the height, we know that this length is 600 meter, and the value of theta, we know that we use sin theta is equal to opposite by hypotenuse to find the value of the hypotenuse, or the equation for the hypotenuse, that is 600 sin theta, and we initially find the value of sine theta, that is 0.12. So we put all this value in this expression and find the change in gravitational potential energy, that is 115,200. And the 600 meter, we find this distance from the expression of constant speed. Since speed is constant, therefore distance is equal to vt, or you can use this s is equal to ut plus half at square. And since it is moving at a constant speed, therefore acceleration is 0, and therefore this part is 0, and distance is equal to ut or vt. We use this expression to find the change in gravitational potential energy. Then, given that the total work done by the engine in this time is 1960 kilojoule, find the constant force resisting the motion. So we need to find the resistive force. But to find this resistive force, we know that the work done due to resistance is downwards. So we need to consider two scenarios, that is initial and final. Initially, gravitational potential energy is 0, and since it is moving at a constant speed, so kinetic energy is same for both these terms or both these scenarios. Kinetic energy is same, so we can eliminate this initially. And the work done by driving force is equal to force into distance, that is this one, work done by the engine or the driving force. And the final gravitational potential energy is, we have found it initially, that is 115,200. And the work done due to resistance, that is work done due to resistive force, is equal to force into distance. Force, we consider this force as r, or resistive force, and the distance we have calculated initially, that is 600 meter. And we equate this, that is initial is equal to final, and find the value of r, that is 1346.667 Newton. Then part C, calculate in kilowatt the power developed by the car engine. So we need to find the power developed, and we know that power is equal to driving force into velocity. So for this, driving force is acting upwards, while resistive force has a value of 1346.667. We have calculated this initially, and we know that this is the resistive force, or R, and the downward component of weight is this. So we equate this, that is the driving force is equal to R plus downward component of weight, and we find the value of driving force that is given. We know that the value of driving force, so we can calculate the power, that is power is equal to driving force into velocity. And since velocity is given here is constant in the initial question, so, and there is no further change in velocity given in the question, so we can consider that the velocity is constant, that is 20 meter per second. So for this velocity, we find the change in, or the value of power, that is driving force into velocity, in terms of kilowatt, or we can use this equation, that is power is equal to work done by time taken, but it is rarely used, because sometimes we don't know the power, we don't know the work. So for this expression, we know that the work done by the engine, that is given here in the question B, that is 1960 kilojoules, 1960 to the power 3 joules, divided by time taken. We know that the value of time, that is initially given in question number 1A, that is 30 seconds. So for this time interval, we find the power same as this. So you can use either of these two, but it would be safe because to use this instead of this, because this information is splitted upon two questions, but this information is naturally occurring or usually given in the first part of the question. Given that the power is suddenly decreased by 15%, power suddenly decreased by 15%, that means final power is 85% of the initial power. So 100% is 65.3, we have calculated this initially, and 85% is 55.05 kilowatt. So for this decrease in 15% power, find the instantaneous deceleration of the car. So we need to find the instantaneous deceleration. So for the deceleration, at some instant, we need to first find the driving force. That is, driving force is equal to power by velocity, and since velocity is not changing, so we use 20 meter per second. That is given at the top of the question number 5, that is 20 meter per second. So driving force is equal to power by velocity. We have the value of driving force minus resistive force is equal to mass into acceleration. So driving force and the resistive force that we calculated in B, that is 1346.667 is equal driving force minus resistive force. Also there is a resisting force, that is the downward component of weight. We subtract it and equal to mass into acceleration. We equate this to calculate the value of acceleration, that is negative. Since acceleration is negative, that means we have a deceleration. So deceleration is positive, that is 0.307. Question number 6. A particle moves in a straight line starting from point O and comes to rest 14 seconds later. So after 14 seconds it comes to rest, that is velocity is equal to 0. At time t seconds after leaving O, the velocity of the particle p is given by, we have two expressions for time 0 to 6 seconds and for 6 to 14 seconds. Where p and q are positive values, positive constant values, that means this value are not changing. The acceleration of p is 0 at time t is equal to 2. So for time t is equal to 2, acceleration is 0. That means between this time there is a 0 acceleration that we have to consider. Given that there is no instantaneous change in the velocity, so we have given that there is no instantaneous change in velocity. Whenever this mentions about instantaneous change in velocity, then we have to consider this instant, that is 6 seconds, and this is 6 seconds, because these two instants are different in both the cases due to different expression. So whenever it mentions about instantaneous change, we have to think about these two change or these two different expression, and at this time these two values are the same. That means at 6 seconds the value that we get velocity from this expression and this expression are same. Find the value of p and q. So as it mentions that instantaneous change in velocity is same, so for time t is equal to 6, as we know that whenever we put the value of t, we can find the value of velocity from this expression. So put the value of t and find the velocity as 36 meter per second and use this velocity for for expression number 1, where t is equal to 6 and velocity is equal to 36. We put these values in expression 1 since no instantaneous change in velocity. So we put these values in expression 1 and find an equation in terms of p and q and referred as equation 1. Then as we have given another information, that is acceleration is 0 when time t is equal to 2. So for this velocity that is in expression 1, we differentiate it to calculate an expression for acceleration, and we place the value of time t is equal to 2 and acceleration is equal to 0 to calculate our second expression. Then solve it simultaneously to calculate the value of p and q. Then we have to sketch the velocity time graph. Now this is important part. As we can see that from our initial expression we have written here is, this is the initial expression of the first expression and this is the second expression. And for the first expression, as we can see that this is a quadratic equation, so this would be a curve sloping upwards or downwards. And as we can see that it is positive. Since it is positive, thus it has a minimum point. If it would be negative, then it would have a maximum point, but for this time it is positive, so we have a minimum point. And we know that at minimum point dv by dt is equal to 0, that means acceleration is 0. So the minimum point occurs when time t is equal to 2, that is acceleration is given here is 0. Acceleration is 0 when time t is equal to 2. So here acceleration is 0, and for time t is equal to 2, we put the value of 2 in our first expression to calculate the velocity at time t is equal to 2, that is 2 and minus 12. And we also know that as it is a quadratic function, so it would somewhat cut the x-axis at some point. So we would consider velocity is equal to 0 and the expression of velocity is equal to 0 and use this to find the value of t, that is 4. So 4 and 0 is our second point. Then for time t is equal to 6 seconds, that is the highest range of this expression, we put the value of time t is equal to 6 to find the value of velocity, that is 36. So we have drawn this point as well. Then as we can see that this is a straight line equation, since we have just t in this expression, neither of t cube or t square. Thus as there is only t, so this is a straight line equation. So we put the highest and the lowest value of t, that is 6 and 14, to draw this line, and after plotting this we draw a smooth, or try to draw a smooth curve or graph. Then in C, find the total distance traveled by P during 14 seconds. So for that time period of 14 seconds, that means the total time, that is 14 seconds, we need to find the distance traveled. So the distance traveled for this 14 seconds, we know that we can use this expression or this graph to find our value. So from time t is equal to 0 to time t is equal to 4, we have to integrate distance, integrate velocity, and find the value of expression for distance. Then we put these values to, actually this is not a distance, since we use velocity in this expression, we would get an expression for displacement, but we have to consider modulus, and whatever the value that is negative, it would be positive, since it is displacement, not a distance, and we need to find here is distance. So we need to find the value of distance between 4 to 0. Then from 4 to 6, by using the same expression, we have to integrate it between range of 6 and 4. Then as we can see that this is a straight line, so we can consider this as a triangle, and we know the value of base, that is 14 minus 6, and the value of height, that is 36. So use this expression to find our third point, displacement. So for this question, we have considered displacement in 3 different parts. We are saying displacement because we have to integrate, we have to use modulus sign to make this displacement value positive, that is negative 32 to positive 32 plus 32 plus 144, and we find our final distance as 208 meter. Question number 7. Two particles A and B of mass 2 kg and 3 kg respectively. That means the mass of A is 2 kg or 2g, weight 18 downwards, and the mass of B is 3 kg or 3g, weight 18 downwards, vertically downwards. Particle B is on the smooth plane, that means there is no friction in this plane. So no friction in this plane, which is at an angle of 18 degree to the horizontal. So here this angle is 18 degree, and the string passes over a smooth pulley at the top of the plane. That means this pulley is smooth, that means here is no friction, that means there is also no friction here. So the particle A hangs vertically below the pulley and is 0.45 meter above the ground. So particle A is 0.45 meter above the ground. The system is released from rest and the string is taut. When A reaches the ground, since it states that A reaches the ground, that means the system moves in such a way that is A is moving downwards and B is moving upwards. The string breaks. Find the total distance by B before coming instantaneously to rest. Since it comes instantaneously rest due to, first of all, it travels the same distance that is traveled by A, that is 0.45 meter. Then after the string breaks, due to its motion, it would keep moving upwards unless its downward weight component causes it to decelerate to 0, suppose at this point. So we have to find the distance when it comes momentarily to rest. So for this distance, we know the initial distance traveled by B, that means the distance when A is connected is 0.45, and we need to find this distance, and for this distance we have done this long expression. So we know that the distance is we know that final velocity, that means here v is equal to 0. Final velocity is 0. So we can use the expression v square minus u square is equal to 2as. And for this expression that we follow, we need to first find the initial acceleration, that means when they are connected. When they are connected, as a is moving downwards, so its downward component minus upward component is equal to mass into acceleration. And for b, here it is for a, and for b its upward component, that means t, minus downward component is equal to mass into acceleration. We solve it simultaneously to find the value of a, that is 2.145 meter per second square when they are connected. And when they are connected, we know the acceleration. So for this acceleration, we need to find the final velocity, that means when b comes to final velocity, that means when they are connected, their b's final velocity, that means when they are connected, the final velocity of b is some value, and after it is released, suppose this is v, and after it is released, it comes to rest, but when they are connected, v has some value. So the value of v would be v square minus u square, initially at rest, so u is 0, is equal to 2as. We know that the distance is 0.45 meter as they are connected, so the value of v is 1.389 meter per second. We know that the value of v, as we know the value of v, now we can consider this as u. Consider this as u because our final velocity after the connection or after the string breaks, we can consider this as u, and the final velocity is 0. So for this term or this scenario, we need to find the acceleration, because acceleration or deceleration, as it is negative acceleration since v becomes 0, so negative acceleration we need to find due to the downward component causing it to decrease to 0. So downward component, that is minus downward component, since it is acting downwards, is equal to mass into acceleration. So acceleration is negative 3.09 meter per second square since it decelerates. So we put this in the expression v square, where v is 0, u, we have calculated this initially, that is 1.389 is equal to 2as. We need to find the value of s, and we have calculated the value of a, that is negative 0.39, that causes it to come to rest. So the value of s is 0.312 meter. So the total value of distance is 0.762 meter. Thus we have completed this paper right now. Thank you.